Okay, this is the Unit 4 review that will help prepare you for the test on the 8th or the 9th. So here we go. On the review, you're going to have 4 times, or on the test, you're going to have 4 times where when you factor, you have to factor by grouping because that leading coefficient is not 1. So I'm just going to start with number 2. It tends to be a little bit easier. Simplify each and state the excluded values. If I'm going to simplify, I have to write it in factored form. So for number 2, I noticed one thing. I noticed that the top and the bottom are almost identical. The difference between the top and the bottom is that the top, or the bottom has an extra n. So if I factor an n out, we are left with n squared minus 15n plus 56. Now I also notice that that is what is on top. So right away, this is an entire group. I can consider it an entire group because of all the plus or minuses. It keeps those groups together, those terms together. And because I have the same thing on top right here as I do on bottom, it's not necessary to factor those, factor those in order to cancel. Now there's an n on bottom, which means my final answer is 1 over n. But because you have to list your excluded values, you need to know what can't go into the bottom. In order to determine what can't go into the bottom, you actually do have to factor. So on this one, I've got n times, what multiplies to 56? N minus 7 times n minus 8. And again, the only reason we're doing this is to get our excluded values from here. N cannot be 0. From here, n cannot be 7, and from here, 8. All right, looking at the first one. The first step in factoring, now I'm going to list my factors when I'm done right here. So off to the bottom, I'm going to do all of like the grunt work. On the top, it's all divisible by 5. We would be left with 2 n squared minus 3m minus 5. In order to factor that, we look for 2 numbers that multiply to a negative 10 and add to a negative 3. Those 2 numbers would be negative 5 and 2. So I have to rewrite this so that middle term has been split. And once the middle term is split, I factor by grouping. The first group has an m. We are left with 2m minus m minus 5. The second group doesn't split, so plus 1 times 2m minus 5. They both have a 2m minus 5. And we are left with m plus 1. So the top factors out to be 5 times 2m minus 5 times m plus 1. All right, looking at the bottom group, somehow I've got to squeeze this in. I'm going to pull a 5 out of the bottom. When I do, I am left with 5m squared plus 4m minus 9. I am looking for 2 numbers that multiply to a negative 9 and add, or not negative 9, multiply to a negative 45, add to 4. All right, let's screw up anywhere. So that would be the 5 and 9, right? So I've got 5m squared plus 9m minus 5m. Double check really quick. That multiplies to be your 4, or to be your backing up. That multiplies to be your 45 and adds to be your 4. So we're good. Minus 9. Now Now let's factor by grouping. Make sure the negative goes over here. Looking at the first group, they both have an m. You're left with 5m plus 9. Looking at the second group, they have a negative 1, 5m minus 9. Sorry, that's kind of small and smudged in. All right, so let's relist it. I have the 5 from the initial factoring right here. I have 5m plus 9 that they share. When I take that out of here, I'm left with m minus 1. Now notice a few things. The 5's will cancel. So those go away. I'm actually just going to erase them. Does that bother any of you? I hope not. The 5's go away. The 5 isn't going to give us any sort of excluded value. Does anything else cancel? No. These are really close, but because one is positive and one is negative, they're not going to cancel. So that is my answer. Now we have to list the excluded values. M cannot be from the first one, or from the second one, that's easier, 1. And from the first one, 5m plus 9 cannot be 0, which means 5m cannot be negative 9, which means m cannot be a negative 9/5. Whew, 1 and 2 done. There are 4 times where you have to factor by grouping like you did right here on the test. 4. Everything else is a nice clean factor like over here. All right, number 3. Again, this is an entire group because of the multiply, or because of the add and subtract. So, on the top, we don't really see that leading coefficient being negative very often, but because it is, you have to divide a negative out. And when you do, switch colors. When you do, you're left with n squared minus 5n plus 4. So now you are looking for 2 numbers that multiply to 4 and add to a negative 5. Negative 4, negative 1. All over, let's do it again. I'm looking for 2 numbers that multiply to a negative 24 and add to 2. How about a positive 6 and a negative 4? Would that work? Positive 2, negative 24, yeah. So list our excluded values next. Your excluded values come from the problem, not from the answer. So you have to list the excluded values before you cross stuff off. So from here, n cannot be 4. And from here, n cannot be negative 6. We do not care about the top. Now I've got to cancel, cancel. Final answer, negative n minus 1 over n plus 6. Fantastic. Next question. Ooh, looking at the top, they all are divisible by 3. So 3x, taking it out, I've got x squared plus 14x plus 40. On bottom, take out a 3x. We have x squared plus 5x sorry, I left it minus 50. Okay, let's factor this. I'm going to have an x multiply to 40, add to 14, x plus 10, x plus 4. So we can ignore that one now. On the bottom, I have an x plus 10, x minus 5. So we can ignore this one now. All right, excluded values come from here. Sorry. From here, here, and here. X cannot be, in the first one, 0. From the second one, negative 10. From the last one, 5. Part of our answer. You will be asked to write excluded values on every single part of the test, with the exception of the story problem. But when you add even, we're asking for excluded values. The 3x's will cancel, that's nice. The x plus 10's will cancel, so we are left with x plus 4 over x minus 5. To get extra credit on your test this time, will you please tell me if you prefer seeing it like this? I'm at school right now using my whiteboard, or if you prefer me using my document camera and like writing it on the actual paper and you seeing my hand and anyway, and me doing it at home. So just let me know which one you prefer better. This is the first time I've tried it this way. All right, let's try number 3. Number 5, the difference between the first 4 and number 5 is on number 5, each of these are connected by a multiplier. So each of these is its own separate group, the 70, the p cubed, and the n squared. The negative up here makes it so the n and the 4 have to stay together. But because there is no plus or minus, you can look at each of these pieces individually. So I look at the numbers first, the 70 and the 3. It is both divisible by 10. So I just draw a line in there. I know that my final answer is going to be a fraction. 70 divided by 3 is 7/3. So this has been canceled with that, and we rewrote it. We have 3 p's on top. I took one out of the bottom. So I have p squared. And then you had 2 n's on top. I took one out of the bottom, so you have an n. That is simplified. There's nothing else that you can do. Well, we didn't list our excluded values first. Your excluded values come from the problem, not the answer. So going back here, the p and the n will have its own restriction. And there it is. Okay, number 6. Same thing as number 5. We can look at them individually. So the 24 and the 9 are both divisible by 3. So we get 8/3. There are 2 n's on top and 1 on bottom, so I have an n on top. There are 3 p's on bottom and 2 p's on top, so I would have a p on bottom. And that's all you can do. It bothers me just a little bit to have those not centered. So I'm going to put that 3p right here so it looks better. Call that my answer. And this is nothing. Okay, excluded values from the problem. P right here cannot be 0. From here, n cannot be 0. And those are my restrictions. And what it's doing is it's restricting the domain. So when we graph this, there's going to be certain values of x that we can't graph, and weird things start to happen, but I will show you that next week. Okay, number 7, you're choosing between 2 storage ottomans. One is cylindrical with a height of x plus 7. And a radius of s. The other one is a rectangular prism with a square base of 9x squared and the height of h. Their volume is the same. What is the height of the ottoman? So the idea to find volume, you have to take the base area and you have to multiply it by the height of the prism or the cylinder. So if we find the volume of the prism, so base area is 9x squared times the height, and find the volume of the cylinder. Now in order to do this, you have to find the area of the base. The area of the base is pi r squared, so pi x squared times it by the height. We know that these two volumes are the same. In order to solve this problem, you have to get the height all by itself. So we are going to divide each side by 9x squared. That way the h is alone. 9x squared. Now on the right, the pi and the 9 stay, but the x squared goes away. And then you have that x plus 7. So if I were to simplify this, h equals pi times x plus 7 all over 9. Bum. Done. Okay, let's look at the next one. Number 8. The height of the rectangular prism is 1 less than twice the width. So stop. What do you draw? A rectangular prism. Something like that. The height of the rectangular prism is 1 less than twice the width. If the width, everything here is in terms of the width, which is x. And I don't know this one. We'll call it w or y, it doesn't matter. You cannot make these the same variable though, because we don't know how these two are related to each other. If the volume of the prism is 2x cubed plus 13x squared minus 7, what is the simplified expression for the length of the prism? So let's start by factoring the volume. Off to the side, I'm going to pull out an x. And then I'm going to play the game. We need to find two numbers that multiply to a negative 15 and add to a 13. 14 and 1, so 2x squared plus 14x minus x minus 7. Then we will group it. On the first group, pull out a 2x. We are left with x plus 7. On the second group, pull out a negative 1. We are left with x plus 7. So I think we've got it pretty much factored now. Let's set up the problem. So finding the volume of this based on the picture, we have length times width times height. And based on the factoring that we did, we have x from here, the initial takeout, times x plus 7 here, that they have in common, times 2x minus 1. Now if those are equal, I can set up an equation and I could get the variable we are trying to solve for by itself. If I want w to be alone, I'm going to have to divide both sides by x times 2x minus 1. Divide x times 2x minus 1. The x's will cancel, the 2x minus 1 cancels, x's cancel, 2x minus 1 cancel. Convenient. This has happened every single time we've done this problem. W equals x plus 7. All right, number 9. A square has a side length of 6x minus 7. It is a square. Those will be the same. And it is equal in area to a rectangle with a width. Now, as I do this one, I'm going to factor out a 3. So 3 times 6x minus 7. Notice, convenient, that again happens often. What is the length of the rectangle? So we need to find that. Again, a different variable. I don't know if they are the same or not. I don't know if it's x. But if they're equal in area, I can find the area of the first, find the area of the second, and set them equal to each other. Now the area of the square is going to be 6x minus 7 times 6x minus 7. The area of the rectangle is y times 3 times 6x minus 7. For this particular problem, we are trying to get y all by itself. In order to do that, we need to divide both sides by 3 to cancel those, and by 6x minus 7 to cancel those. So cancel, cancel. My final answer is y equals 6x minus 7 over 3. Okay, number 10. Simplify and state excluded values. So this one is almost identical to the top of the page on the other side. We're going to do the exact same thing as we did before. It's going to require us to factor a little bit more, but it's doable. So, let's factor. I've got a 3x and then an x minus 5 over, multiply to 15 and add to 2. So x multiply to 15, 5, and 3 times multiply to 5, add to 6. Multiply 5, add to 6, there you go. And then on bottom, they both have a 3x, and you are left with x plus 1. So lots going on here. Let's start with the excluded values. X cannot be from here, 5, from here, negative 3, from the other fraction, 0. This 3 has nothing to do with it. It is its own group because it is canceled by a it's connected by a multiplication. So it can't be 0 and it can't be, from our last piece, negative 1. Again, the top has nothing to do with it. Now let's look at canceling. The x plus 1's go, the 3x's go, the x minus 5's go. I believe that's everything. So we are left with x plus 5 over x plus 3. Sweet, number 11. Moving on. Same thing. On the top, what multiplies to a negative? 6 and adds to 5. 6 and 1. The 6 has to be positive, the 1 has to be negative. The next one, they both have an 8b squared. So we're left with 3b plus 10. Now it looks like on top right here, these are identical. So they'll cancel. Again, from the very first question, I need to actually write down the factors right here so that I can write excluded values later. Oh, that's a B. Okay, so excluded values. From the 8b squared, b cannot be 0. From here, b cannot be negative 10 thirds. And then from our last piece right here, it cannot be negative 6. All right, it's canceling time. The entire denominator cancels with this entire numerator. They both have a b plus 6. One top, one bottom. So my final answer is b minus 1. It is okay to have just a numerator. We are about halfway done. Next one, number 12. Still multiply. So 3 over 5b squared times b plus 1 is that denominator. Do you agree? Yes. Times 5b squared times 3b minus 10. On the bottom, pull out a 3. You're left with 3b minus 10. So excluded values, b cannot be from here, 0. From here, negative 1. And from here, I would add the 10, and then divide by 3, so 10 thirds. Time to cancel. Cancel, 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 cancel. Almost everything is gone. Nothing is left on top, so we will put a 1, and then b plus 1. number 13 is the first time that we divide. It's only, I sure hope so. Let me just double check. I didn't misread anything. Everything canceled off nicely. Usually when that happens, I didn't screw up. Yeah. Number 13 is the first time we're dividing. So when we divide, n plus 5 times n minus 1, is that okay? Now when I divide this, I have to change it to a multiply, and I have to flip it. So the 12n squared will be on bottom, and the n minus 9 plus 5 is on top. Is that okay? So we just flipped it and factored at the same time. So when I'm listing my excluded values, I'll do them up here. From the n plus 5 on the bottom, could not be negative 5. From here, 1. From here, 0. Now this is after the flip happened. Before the flip happened, this was the denominator. So this can't be 0 either, which means it can't be 9. All right, canceling. There's not a whole lot that cancels. This is a group. So the n minus 1s will cancel. The n plus 5s will cancel. And that is it. N minus 9 over 12n squared. Sorry, that was fast. Pause it, look at it if you need to. Number 14 and 15 are very close in problem. Number 14 says 2x over 5 over x over 1. This line right here is slightly longer than the other one. On the test, it's a little more obvious. You actually see it better on number 15. Do you see how this is the bigger line? So this is a 2x whole number over 5 over x. So looking at the first one, it would be interesting to see if these are the same. Because the problem looks almost identical. Now this is another way to say divide, right? When I'm dividing fractions, I can actually change it to a multiply and flip them. And when I do, first of all, excluded values, the only thing that's on the bottom is x, so x cannot be 0. And once I flip them, the x's cancel, the one we don't care about, so my answer is 2/5. Okay, let's go to the other one now. We rewrite this as a divide over 5 over x. We can rewrite that 2x over 1 times, flip it, x over 5. And you get 2x squared over 5. Again, still x cannot be 0 because of the denominator right here. So they don't actually end up being the same thing. You're going to have something very similar to this on the test. And to prove that they aren't the same thing, you need to simplify this one, you need to simplify this one, and then you can just say, see, they are not the same. There's a hint for you. There you go, number 16. Now we're talking about adding and subtraction. Now it's adding and subtracting. I would dare say this is the hardest day of the unit. In order to add or subtract something, you have to have a common denominator. And we look at it in groups. Because of the subtraction, it's pulling these, the 2n and the 3 together as a group, and the n and the 1 together as a group. So our common denominator will be 2n minus 3 times n minus 1. Now the first fraction doesn't have the n minus 1, so I'm going to list it right here. The second fraction doesn't have the 2n minus 3, so I will list it right here. Now, just so we don't make the mistake, let's change that to a plus and move the subtract over to the fourth. It is time to distribute. I like to simplify my numerator kind of off to the side over here, and then I'll put my final answer up here. So, 6 n squared minus 6n minus 8n squared plus 12n. Combine like terms, you have negative 2n squared plus 6n. Now, that does factor. If I pull out the negative 2n, we are left with n minus 3. Does anything from right here cancel with anything from over there? No, because nothing cancels, I'm actually going to not worry about this and just use this as the numerator. Okay, number 17. Number 17, let's look at this one. Common denominator is really close, but that minus plus makes a difference. So b plus 1, b minus 1. I'm looking at the first fraction on top and bottom, it needs to be minus 1. The second fraction, b plus 1. So our new denominator, or new numerator, would be 4b squared minus 4b, distribute, plus 2b squared plus 2b. Combine like terms, you get 6b squared, minus 2b. It factors. But does anything from down here cancel with anything from up here? No, so we ignore the factor. 6b squared minus 2b. And that is your final answer. Okay. Number 18. Factor out the 3, n minus 3, 1. Common denominator, n minus 2 times 3 times n minus 1. This fraction needs the n minus 2, and please pardon my laziness. I'm not going to write it on bottom. This one needs the 3n minus 3. Now, did you see what I did there? It needs the 3 and it needs the n minus 1, so I distributed the 3 and kept it like that. And then, of course, on the denominator, it's the same thing. So, when we multiply this through, it is going to be 6n minus 6. Multiply this through, plus 5n minus 10. Combine them, 11n minus 16. Does it factor? No. 11n minus 16. That felt really fast. I hope that you're getting this at this point. Number 19, I'm going to change that to a plus and bring the negative up with the 3. Common denominator, you have to look at this as a group and look at this as a group. So, m minus 1 times m plus 2. Then, the first group will need an m plus 2. The same on the bottom. The second group will need an m minus 1 on the bottom. 2m squared plus 4m minus 3m plus 3. Now, 2m squared plus m plus 3. So let's try this. Is it possible to have two numbers multiply to 6 and add to 1? Well, 6 and 1 when it works, 2 and 3 would if that was negative, but if that's negative, it does not multiply to 6, so it does not factor, which means your answer is 2m squared plus m plus 3 all over that. All right, just a few more. Number 20. Ooh, on 20, let's make that 6p negative. Erase this. Now, I'm going to have to, well, it doesn't ask me to list the excluded values. On the test it will though, but for now it doesn't, and I think that you already know how, I hope. So let's multiply the top and the bottom by, now this is, or let's see, back up, just kidding. I have a lot of reducing that can happen first. I guess I didn't really show this to you, but this is the first time I see it. Notice how the 2, the 4, the 8, and the 6 are all divisible by 2. I'm going to rewrite this fraction as that, because anytime I can deal with smaller numbers, it's easier. And if I can divide a 2 out of the top and the bottom, it's going to be easier. Now, these numbers are both divisible by 3. I did make this a negative, but if I divide it by 3, I have a 2p over 1. That's going to create a simpler problem, because now all we have to do is multiply the top and the bottom of this by p squared plus 4p plus 3. Then, when I distribute, I will have 2p negative 2p cubed minus 8p squared minus 6p, and then taking that one out there, plus 2, so I moved it from here to the end, that's okay, all over p squared plus 4p plus 3. If you don't simplify it first, after you get down to this garbage that I just circled, you're going to have to simplify it because you'll have extra p's in there. No, you won't. You'll have extra 2's and 3's in there, actually. I think an extra 6. Okay, number 21. Again, we could simplify it if we want to. No, there's no need. Plus minus. Let's factor this. If 3 comes out, you're left with, a 3n. That's fun. 3n comes out, you're left with n squared. Well, I'm deciding what to do. I'm going to start over. This has a 3, right? This has a 3. I know it has more than just a 3, but everything else that it has left over, my first fraction does not have. So the common denominator actually is 3n cubed plus 18n squared plus 24n. Because they both have the 3. Now this first fraction needs all of that. So let's multiply it by n cubed plus 6n squared plus 8n. And then you'll have the minus 5 at the end. So let's distribute the 3n to this. So you'd have 3n to the 4th plus 18n cubed plus 24n squared, and then minus 5. All right, number 22. Common denominator is almost there, not quite. X minus 5, x plus 5. The first one needs an x plus 5. The second one needs an x minus 5. That's not an 11. I just realized it looks like an 11. That's kind of like a ditto mark because I'm lazy and I just want to be done. Hopefully you just want to be done too. I have other things I need to do. So distribute the 2. I've got a 2x plus 10 right there. Distribute the 2x. I have plus 2x squared minus 10x. Rewrite it. 2x squared minus 8x plus 10. And it hasn't really been an issue canceling things off, but just in case, let's factor that. Now if this was extremely ugly, I probably wouldn't even worry about it, but it's not terribly ugly. So it multiplies, it's going to be x minus 5, x plus 1 with that. Oh no, that's not going to multiply to the positive 5. So we don't have to worry about it. Which means our final answer is 2x squared minus 8x plus 10 all over x minus 5x plus 5. All right, we're almost done. Let's simplify this to get rid of the denominator, and that will make our problem easier. So let's call this a minus 2a instead with a denominator of 1. Now when I find a common denominator, they both are going to need a 3a plus 15. Is that okay? I just distributed 3a plus 15, which means the common denominator is 3 times a plus 5. So you have the a plus 4, and then distribute minus 6a squared minus 30a. So negative 6a squared minus 29a, we will combine those, plus 4. We are almost done. Okay, number 24. A runner practices running 2 miles up a slope and 2 miles down. So this runner goes up and he goes down. He runs the slope 50% faster than he runs down the slope 50% faster than he runs up. Let R be the runner's, okay, we have the distance equals rate times time. Distance, rate, time. Let R be the runner's speed in miles per hour when running up the slope. So this is R. Now the other one is going to be what? He runs faster going down. So I need to increase his speed by 50%. That 0.5 here is 50%. The 1 stands for how fast he runs going up, and then the 50% is the 0.5. Together make 1.5. There we go. Now, how far did he go? 2 miles, ran 2 miles, then ran 2 miles back. If distance equals rate times time, time equals distance over rate, divided by R. So to write an expression here, I'm going to say 2 over R, and then 2 over 1.5 R. So it's going to be 2, if I want the total distance, common denominator is 1.5 R. So I get 3 over 1.5 R plus 2 over 1.5 R equals 5 over 1.5 R. Except for you can't have a decimal inside of a fraction, so let's multiply it by 10. 50 over 15R. Now you've created the problem that there is a reducing situation. Divide the top and the bottom by 5, so you get 10 over 3R. One more, and then maybe we'll take a second and look at your project for a minute. So let's maybe do 1 or 2 of those. The school secretary has 2 displays to set up on the bulletin for Thanksgiving. Find the total area of the display case that the secretary has to fill if one picture is a square with side length 2x plus 3. The other is a rectangle with a width of 5. I'm going to call this 2x plus 3. Is that okay? Kind of factor it out as I go. 1 over x plus 2. So if I want to find the what? Total area, right there. I'm going to find the area of the first one, find the area of the second one, and add them together. So the area of the first, we just multiply it together. 2 times 2 would be 4. So like that. Because you're just multiplying, right? That's the square. The rectangle, and I multiplied those. I get that, and to find the total area, I add them together. So my common denominator, what do they share? They share this one and they share this one. I will write that down first. Now this one has an x plus 3, that one doesn't. So I will write it down. This one has an x plus 2, that one doesn't. I will write it down. This one has a 2, that one doesn't. I will write it down. So this is the common denominator. You don't have to list 3 of the x plus 3s because one of them they share. Now, if I want to fix my numerator, looking at this denominator, it needs a 2. It has both of the x plus 3s, it needs an x plus 2. Looking at my second fraction, it has the x plus 3. It has the x plus 2. It has the 2. It only needs another x plus 3. So, combine those. Make it an 8. We're distributing an 8. I'll do it off to the side. You got 8x plus 16 plus, distribute, 5x plus 15. Add those together, you get 13x plus 31. There you have it. Okay, give me 1 second and I am going to pull up the project. All right, there were some really confusing ones on this page. I'll do one from this and then one from the other worksheet. I think on this one, I want to do the perimeter. No, I'm going to do the cow pasture that's being made into the duck. Whatever we called it. So your uncle decides that he wants to add ducks to his farm and will take a portion of the cow pasture to do it. He wants to take 1/8 of the width and 1/3 of the length. What is the area of the new duck enclosure? So really quick, what I'm going to do is I'm going to come down here and I'm just going to write what the original cow dimensions are. So in the cow pasture, this length right here is x over I think I actually did this one wrong, but I have to do it. I'm glad we're doing this together. This length is x squared minus 3x over 9. Okay, now if I wanted to take a half of something, or a third of something, or a fourth of something, for example, you all are half my age. What do we do to figure out from my age? I know I'm 35. What do we do to figure out your age? Well, we take the 34 still until next week. We take my 34, we divide it by 2, we get your 17. So if I want to do a third or an x, we're either going to multiply by 1 over x, or we divide by x. Isn't that the same thing? Multiplying by the reciprocal is the same as dividing by the thing. The answer to that is yes. Now if I want to take an x of the width, we are going to times this by 1 over x. If I want to take a third of the length, I'm going to times this by 1 over 3. And then once I do that, we want to find the area of the duck enclosure. So basically, if this is x, this is a third, this is the new duck enclosure. We want to find the area of that. Now, I don't know how long this is. I know this is 1/3 of the total. This is 1x of the total. That doesn't really matter though. Okay, let's multiply these together. What's going to happen happen is you have an x on top and an x on bottom, and you're left with 1 over, I'm going to factor it right now because I can. That's in your width of the duct, whatever I call it, the duct what? Enclosure. The duct enclosure is 1 over x minus 3x plus 3. This one, if I factor it out, and then I multiply these together, it's going to be over 27. Nothing ends up canceling on that second equation. Now if I want the new area, I have to take the area, or the side length here, and the side length here, and multiply those two numbers together to find the new area of my duct enclosure. So what happens here? You have canceling that will happen, and that's it actually. So x over 27 times x plus 3. I'm pretty sure I didn't get that in there, right, Dan? So there you go. That's a free question for you. Let's look at number 3 on the extra story problems page. A moving van gets 25% better gas mileage when it's empty versus when it's full. So, yes, it's getting better gas mileage, but this right here all depends on where my variable is going. A moving company transfers a family's belongings, so its gas mileage, pause for a second, the gallons you use is equal to the distance you drive over your miles per gallon. So when we set up our chart, we have one that's going fully loaded, and the other one's going empty, right? So what's going to happen here? A moving van company transfers the family's belongings 120 miles from their home, and then returns the van to a storage unit. So in every case we've gone so far, somebody's gone out and then they've come back. So their distance has been the same. This time, the moving van goes 120 miles and then it goes to a storage unit 60 miles away. Excuse me. So it's not like I'm going out 120 and coming back 120. I'm going out 120 and then I'm going to a different location 60 miles. This is when I'm empty. This is when I'm full. That has nothing to do with the problem, it just hopefully helps. I need a gallon, a distance, a rate, and a fraction. Alright, a moving company transfers the family's belongings 120 miles, so they're loaded, they're transferring the belongings from their home, and then returns the van to the storage unit 60 miles away. So maybe I should have put returns the van empty to the storage unit 60 miles away. Again, this is the first time that those numbers have not been the same. Here's the key. If G represents the gas mileage used when the van is empty, G, write an expression that represents the number of gallons the gas of the truck. Now, this is when it's empty. Is my gas mileage improved or decreased based on when it's empty? If it was fully loaded, my gas mileage would be worse, right? How much worse? 25% worse. Does that make sense? Yes, I'm getting better gas mileage when it's empty, but if G is when it's empty, that means I have to deduct gas mileage when it's full. Now if I'm coming up with the gallons, 120 over 0.75 G, 60 over G are my two expressions. If I want the total number of gallons, we are going to say 120 over 0.75 G plus 60 over G. In a second, I'm going to erase my little sketch here. Can't really leave myself much room to write. We need a common denominator. Multiply the top and the bottom by 0.75. Let me get my answer key so I don't have to use a calculator. This becomes right here 45. So when I add them together, I'm going to have 165 over 0.75 G. And then I didn't try this. Let's just try dividing that, see if it goes in evenly. It will. It does. When I divide this, the 165, so this is what I just did on my calculator, you can't see it. I did 165 divided by 0.75, and I got 220. So it's going to be 220 over G. All right, so you get 2 free questions on the review, or on the project. I gave you 7 questions, or no, just kidding, 15, which means you only had to do 13, and I just did 2 of those 13 for you, so that's a guaranteed 2 out of the whatever correct, 2 out of the 13 correct. I hope that today's project was helpful. That was the goal, obviously. I want you to do well on this test. I care about your success. I really like you guys. I'm so glad that you chose me as your teacher, and hopefully it was because you thought that I was good and not because there was no other choices. Doesn't really matter. Again, tell me if you liked it this way or if you would prefer me just doing it on a piece of paper. There are perks both ways. Anyway, good luck. Have a good weekend. Peace out. I love you all. Bye.